Good day everyone, and welcome to my video on inequality. So let us begin. Logarithmic inequalities are inequalities in which one or both sides involve a logarithm. Like exponential inequalities, they are useful in analyzing situations involving repeated multiplication, such as in the cases of interest and exponential decay. The key to working with logarithmic inequalities is the following fact. If a is greater than 1 and x is greater than y, then log ax is greater than log ay. Otherwise, if 0 is less than a and a is less than 1, then log ax is less than log ay. Of course, the base of a logarithm cannot be 1 or non-positive. More importantly, the converse is true as well. If a is greater than 1 and log ax is greater than log ay, then x is greater than y. Otherwise, if 0 is less than a and a is less than 1, then x is less than y. So in the next two slides, I will be presenting two examples on how to solve logarithmic inequalities. These are very simple examples. So we have here the first example. Log 3x plus 4 is less than log 3x. So in order to solve logarithms, all you need to do is cancel the logs. So cancel the log 3. So and you end up with x plus 4 is less than 3x, and then you substitute. You transpose the x so that this becomes minus. So 3x minus x is equal to 2x. So and then 4, and then you divide both sides by 2. So the 2's cancel out, and then you end up with 2 is less than x, or x is greater than 2. And you have found one of the critical values. In order to solve a logarithm, you need to find 3 critical values. To find the other 2, so we just take x plus 4 and then greater than 0. So all you have to do is move 4 to the other side and change its sign, so it becomes x is greater than negative 4. And then to get the third one, you just have to get 3x here and then equate it to 0. So 3x is greater than 0. So divide both sides by x. So we get x is greater than 0. So we need to test. This is the second step. We need to test if our critical values are correct or not. So all I have to do is substitute the x. So we have here 2. So log 3 2 plus 4 is less than log 3 3 times 2. So just cancel the logs and then calculate the numbers on the inside. So 2 plus 4 is 6. 3 times 2 is 6. So this is 6 is less than 6. So this is obviously false. And then we go to the other critical value. So log 3 negative 4 plus 4 is less than log 3 3 times negative 4. So cancel the logs, and then you end up with negative 4 plus 4 is less than 3 times negative 4. So negative 4 plus 4 is 0. 3 times negative 4 is negative 12. So this is obviously false. And then we go to the third critical value. So log 3 0 plus 4 is less than log 3 3 times 0. So cancel the logs again. So you end up with 0 plus 4 is less than 3 times 0. So 0 plus 4 is 4. 3 times 0 is 0. So 4 is less than 0. This is obviously false. Then the third step is to make a number line. So we have here a number line, and then plot your critical values. So in a number line, so we have here negative 4, we have here 0, and we have here 2. And then you draw a circle, like a circle, and you shade this circle if your critical value is true. If 5, example, if 5 is actually what we got, so we got 6, and this is obviously wrong. So get wrong here. This is false. And then here we the line, the arrow pointing, it depends on the inequality sign. If it's greater than, goes to the right. If it's less than, goes to the left. So it's greater than, it goes to the right. Same here with 0, it's wrong, so we don't shade the circle. So and the arrow goes to the right as well. And -4 here, we draw a circle with no shade because it's wrong, and then we just draw the arrow here, and the arrow points, I mean the line here, and the arrow points to the right because of the greater than sign. And the final answer is their intersection point. So they intersect around this area right here. So this is 2 to infinity. So the solution set is 2 to the infinity. So let's move on to the second. Log 2 5x minus 2 is greater than or equal to log 2x plus 4. So yes, same process, cancel out the logs. So you end up with 5x minus 2 is greater than or equal to x plus 4. And then you move the variable to the left hand side, and then move the number or the constant to the right hand side. So 5x minus x is 4x. 4 plus 2 is 6 over, so divide both sides by 4 and you get x is greater than or equal to 3 halves. So we got the first critical value, so we need to get the second critical value. 5x minus 2 is greater than 0, so 5x over 5 is, and then you move the 2 here, so 2 over 5, and then you end up with x is greater than 2 over 5, and then we pick the third critical value. X plus 4 is greater than 0, so you just move the 4 to the right hand side and change its sign. So now our third critical value is x is greater than -4. So our log 2, just substitute the critical value. So we have here 3 halves and 3 halves. So 5 times 3 halves minus 2 is 11 halves. 3 halves plus 4 is 11 halves. This is obviously true. And then here we have 5 times 2 over 5 minus 2 is 0. 2 over 5 plus 4 is 22 over 5. This is obviously false. And 5 times -4 minus 2 is -22. And -4 plus 4 is 0. So this is also false. And then we do the number line here again. And we plot our critical values, -4, 2 over 5, and 3 halves. So we shade the circle for 3 halves because it is a true critical values, and then the arrow points to the right as well. We don't shade it here because it's false, and the arrow points to the right as well, and we don't shade it here for -4, and the arrow points to the right as well because of the greater than sign, and our intersection is right about here around the start of 3 halves, so to infinity. So the solution set is 3 halves infinity. So and that's it for today. I hope you learned something, and I hope you'll get a good grade on your quiz. Thank you.